sand dunes and salty air. Strange little villages here and there. Coolsies! Okay, I'm talking. That's awesome. I'm assuming you can hear me. If you can't, please send a message. Okay, cool, guys. As per last week, if you weren't here, you would not know the surprise. This week, we're doing something a little bit different because I needed a break from mammals. So we're doing a short little lesson on the biomes of South Africa. It might be a two-parter depending on how much we get through today. But yeah, so this is going to be the biomes of South Africa, and then next week we're getting into elephants and their cousins and all their related species. But I just needed a bit of change of scenery for 1 week because I'm severely ADD and I get bored. Okay, cool. So taking it away we go. So, biomes of South Africa. We've got a question chat. I'm recruited with horsey people. They want to know when horses were domesticated. Around, what was it? I think around 4000 BC. They were domesticated, Michelle, but we'll do a little bit of a Q&A later. Okay, cool. So going forward. Okay, cool, that's done. Okay, so the book of the week is a fairly hard, actually no, it's not hard to find book. It's out of publication, but you can find it in almost every secondhand bookstore that I've ever been to. Most of the SPCAs carry a copy, and any decent secondhand bookseller should have a copy floating around somewhere. Fantastic book, not just about the flora and the fauna, but also just about holiday making in South Africa. It's a bit outdated in that respect because it was written in the late 80s, so a lot of the what's the word I'm looking for? Like the financial backgrounding and the safety of areas has changed. So, like it's some areas become more upmarket, some areas become more down market. So that aspect's changed a bit, but in terms of its actual flora, its fauna, really interesting book to read. A nice comprehensive guide to the coastlines. Okay, so people don't understand that in South Africa, the climates and the currents are intrinsically linked to the biomes. The biomes just don't happen of their own volition, of their own free will. The climates actually play a major role in our biomes and how they behave. So if you guys have ever done high school geography, I'm sure you all have, or at least primary school geography, you should know we have the warm Agulhas sweeping down the coast from the western, on the eastern shores. And along the western coastline, we have the cold Benguela current sweeping up from the Antarctic. Of course, Durban, PE, Port Elizabeth, and so on down the coast, Cape Town over there, creating two very different types of climates. So one thing that you'll notice wherever you go in the world, in the southern hemisphere, on the eastern coast, water tends to sweep down the coastline, and on the western side of the country or the western side of the continent, it tends to sweep up the coastline, okay, towards the equator. And that's whether you're in Australia, whether you're in South Africa, whether you're in South America, it's the same rules apply. And that creates very comparable environments in all these areas. So you'll find comparable environments in Western Australia, the Western Cape, and the Western South America. Of course, the vegetation is very different. When I say different, I mean they are different species, but they actually are in many ways phenotypically, in terms of their appearance, very similar. And again, on the eastern shore is very similar as well. So you'll find very similar environments appearing because of the currents. So, and this is all to do with the Coriolis effect. The world spins in this direction from west to east, and because of this, you get this Coriolis effect forming, creating similar currents where you are around the world. And we're not going to get into that because that begins more about climate and weather, and we're just going to, it's a fantastic term to remember, the Coriolis effect. And it's intrinsically linked to why the currents flow the way they do. Air currents and water currents both flow roughly the same way. So what you also see in South Africa is that we have two major plates in Africa, and South Africa rides both of them. So we've got the African plate, which is the Somali plate, and the Nubian African plate, which is the bigger plate, running through the Mariana Trench over here, and you've got the Indian Ridge over here. Now, what people don't also realize is that our geography is not just linked to the land, it's directly linked to the sea as well. So all the land underneath the sea is as important to us as the land that's accessible to us. And that plays an aspect with our climate and our soil types, and yada, 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 and of course, our biomes. So the Atlantic Ocean, because of the Mariana Trench, is substantially deeper than the Indian Ocean, okay? And so you've got very cold water sweeping up through a very deep, very refrigerated ocean, okay? Coming up the coastline, through very deep, very cold waters. And you've got very shallow water with warm water coming down the coast towards the Cape, okay? And creating again, so you've got very warm water and very cold water clashing against each other, having very different effects on the country. So because of this, we also start to see that very similar things appear across the whole of the eastern half of South Africa, and of course the western half of South Africa. It's more or less unilaterally the same all the way down. The equatorial belt is a bit of a long story. We're not going to get into that, but along the equator it tends to be very tropical. What you'll see over here is that between Madagascar and Mozambique, the water is also extremely shallow. I mean, you can't stand in it. I mean, you could sink a ship in it. But compared to the Mariana Trench, it's very, very shallow. I don't even think it's as deep as a kilometer in most places. So you've got this very sandy water, very, very sandy soil at the bottom over there. You've got very shallow waters, and you've got quite a strong current sweeping water through this, creating this very lush tropical environment over here. So you've got superheated water, and it's extremely tropical. It's wonderful there. Why people, why Mozambique and Madagascar are such mess ups in terms of their economy, I don't know, because they're tropical paradises, or they should be, except logging and all that is becoming an issue. So what you also have, again, is you have this current sweeping around Madagascar, sweeping through that channel between Madagascar and Mozambique, and finally channeling into KwaZulu-Natal. And remember, borders don't dictate climates and temperatures and ecology. That's a human concept. So we tend to ignore what's happening 50 kilometers north of the border, and we're saying, well, why is this happening? Because we're not paying attention to what's happening in Mozambique or Madagascar or Namibia. We don't really seem to think outside our little man-made borders, and that's why we have very poor understanding of our ecosystems and our biomes, because these human constructs trying to predefine political boundaries. I never knew that ferns had any political allegiances, or palm trees for that matter, any political affiliations. So what you'll find is that these have impacts on the climates in the southern hemisphere. So because of this water, because of this cold water on the, coming up from the Antarctic, western coastlines tend to be drier and cooler and have a more Mediterranean climate. So on the western shores of South America, the western shores of Australia, and the western shores of South Africa, dry and cool, and with Mediterranean climates. On the eastern shores, it's subtropical to tropical and very humid, especially in South Africa and Mozambique because of that channel. What's also people don't realize is that the geology plays a major aspect as well. The topography of the landscape, the shape of the landscape is really important for understanding why the climates are the way they are, and why the certain plant species grow in certain areas. The geography and the geology and the topography are all intrinsically linked to that as well. And what you'll see over here, this is quite a comprehensive map. We've got the Cape Fold Mountains over here with very acidic, very silicate type soils. We've got this very, very, very young soil coming down the coastline over here from Mozambique, which tends to be very sandy. It's very recent. Some of it's not more than 1 million years old. We've got the Bushveld supergroup over here. We've got the Karroo group over here. We've got the Drakensberg escarpment over here, all creating very, very different types of geological conditions. And they absorb heat at different temperatures. They lose water at different rates, and they all play their own roles. Again, you can see over here the topography of the landscape. So green being the lowest and white being the highest. So you have this wonderful ridge. Of course, we all know about the Drakensberg, but it literally cuts the country in half, creating two different habitats. It sweeps around the Highveld through to the Magaliesberg, and again creates very, very different habitats and creates this wonderful little natural border separating habitats and separating biomes. Okay, now what you can also see is a cross-section of South Africa over here. We've got the eastern shores over here, which is KwaZulu-Natal, then this massive escarpment, okay, coming up, creating the central plateau with the Karroo supergroup being pretty much the whole entirety of the country. The Cape supergroup is about 600 million years old. This Karroo supergroup, or depending on the geology, can be up to 2,000 million years old. And again, just the different landscapes create different types of habitats. It's very, very, the weather is very mercurial in the Cape because not only is the actual ocean pattern very mercurial, but the landscape is very choppy and broken up and creates all these microclimates. And those microclimates can play hell with the macroclimate. We're a lot more predictable on the Central Plateau and also down coming off the escarpment because the landscape becomes more predictable and weather responds more predictably. And what you can see over here, if you go back to the actual topography of South Africa and the biomes of the South Africa, they kind of overlap each other. So if you look at the soil types, the geology, and you look at the biomes, very similar. My favorite example, of course, is the Cape Fold Mountains being both geologically separate and also in terms of its plant life separate. The two are intrinsically linked. The plant life has only adapted to living on that type of environment. And that's why it really grinds my gears when people are trying to plant protea species and Fynbos species in Johannesburg because they want their garden to look like the Cape. Bloody well move to the Cape, you know. If you live in the Highveld, try and enjoy a Highveld garden. Plant grasses and sedges and shrubs and that sort of thing, and try have a Highveld garden. So we've got quite a few biomes in South Africa. We've got some of the highest diversity of biomes in the world. The only thing that we don't have is tundra, but in all respects, we've got pretty much all biomes known to man. So we've got deserts, we've got the succulent Karroo, we've got Fynbos forests, which are pretty poor in South Africa. The Albany thicket, which is just another word for thicket. The Nama Karroo, which is xeric scrubland. The grasslands, which are pretty prolific, one of our largest. Savannah, which is our largest biome. And the Indian Ocean coastal belt, which is, yay, KZN, a little bit of the Eastern Cape. And if you're from the coast of KZN, this is a pretty cool biome to live in. So the first group we're going to be talking today is about the Indian Ocean coastal belt. This is it over here. This is Isimangaliso Wetland Park. And pretty much before Europeans arrived here and killed everything and shot everything out and changed it all into farmland, this is what the coast of KwaZulu-Natal looked like. It was this beautiful semi-jungle mixture of grasslands, swamps, wonderful sand forests, all these deltas and estuaries, and then Europeans came along and said, you know what, it would look great with jacarandas, bougainvilleas, and gum trees, and they just destroyed most of it. So we've got a few little protected areas, but most of it is stuffed. If you've been to Durban or Richards Bay, you know what I'm talking about. Okay, so it extends an almost 800-kilometer strip from the Mozambican border, not quite the border, actually quite far up into Mozambique, right down to the Great K River in the Eastern Cape. The landscapes are usually flat in the north and become progressively more rugged to the south with deep-cut river valleys. And that's the deep cut simply because of the geology. The soil tends to be very soft in this province. We have a lot of shale, which is very soft and erodes very easily. So our rivers tend to be quite deep. They're not these very wide, open rivers that you get like in the Amazon, which flows very smoothly. And again, it varies from area to area. In the north, it's about 35 kilometers wide because we've got this wonderful stretch of sand forest in the north. But once you get further down the coast, that sand forest gets progressively thinner and thinner and thinner. And it's the youngest biome in the region. And specifically because of the fact that it's almost entirely reliant on that current coming down between Mozambique and Madagascar. And as silicate material, as sand is actually deposited along the coastline, it's constantly extending out that coastline. So it actually is reinventing itself every couple of million years. And if you went back 700,000 years ago, the coastline of South Africa was really only to Swaziland. And that if you go to Tembe Elephant Park would have been underwater 700,000 years ago. Tembe Elephant Park is a sand forest today because it was all coastal sand dunes over the last couple of 100,000 years. And if you go to Durban in 500,000 years' time, that'll all be 50 kilometers inland. And the actual coast of Durban will be 50 kilometers out to sea, or probably 100 kilometers out to sea. So we have this wonderfully expanding eastern coastline. The western coastline is a lot more static by comparison. And it's described as having a dominant forest cover interrupted by areas of grassland. And that's usually just to do with the actual the saturation of the water. A lot of the time, the water, those very marshy areas actually don't facilitate the growth of trees. So you get these very wet, marshy grassland areas forming. And it has a slightly tropical appearance, but again, that varies from area and from season to season. Sometimes you go through a drought and it's less tropical. It's hot and damp and tropical in summer and is much more mild. It's never really cold in winter. And the summers are hot to very hot. Winters are typically mild. And the far north is very non-seasonal rainfall, but it's quite predictable compared to the Cape. And we get quite a lot of rainfall, about 1.2 meters annually. In some areas, are only around 80 centimeters, so not that much. And the waters, again, as I explained, were very, very warm and very, very shallow. Are very warm and very shallow. And the marine environments are home to large coral reefs and mangrove swamps. And we'll get into a bit of detail about why mangrove swamps and coral reefs form on the eastern shores of countries and less so on the western shores. In the northern hemisphere, it's a little bit different, but the southern hemisphere tends to be the same sort of themes recurring. So this is our wonderful Indian Ocean coastal belt and how it would have formed. And as you can see, these grasslands actually forming more in these pans, in these very, very wet, marshy areas where trees basically don't get a chance to grow because they rot. And the grasses really just grow on the top of these surfaces. So a lot of the area looks quite dry, but it's like slogging through mud. Now, what you'll see is with water in warm conditions tend to expand. So, and with water in cold conditions tends to contract. So when water is in warm conditions, it expands and actually leaves fewer spaces for other molecules, be it carbon, oxygen, nitrogen, whatever nutrients you may have in the water. And because the actual space between the water molecules is reduced, really, there's fewer nutrients. There are fewer nutrients in that water. So warm water holds fewer nutrients because of this, and they also evaporate more readily, so it leads to a greater humidity. So it tends to have fewer nutrients and it tends to be far more humid in the area. And the lower resources in this water leads to increased competition. So because there's a lot of competition in warm waters, because there are actually fewer nutrients being held in that water, there's a lot more adaptability, or a lot more adaptation. So you tend to have lower populations and higher diversity. So there's a lot more complexity in the ecosystems because everything has to find a specific niche to live within. So you're going to start finding on the eastern coastlines, coral reefs, highly complex coral reefs developing with thousands of species living in it. And again, you're going to find very, very prolific swamps and deltas where you're going to have lots of species, exceedingly high numbers of bird life and mammal life and fish life breeding in these areas. Because again, although it looks very productive, in terms of its resources, it's actually not. There's not much in that water. So it tends to be a bit of it was actually called Darwin's paradox. He wondered why so many marine species thrived in these nutrient dead areas. So, and then later they actually solved the answer, but that's a whole other course with marine ecology. So Darwin's paradox, look it up. And again, you get extremely high diversity with fish life and with all marine life. Because there's so few nutrients, everything has to adapt to a specific niche and find a specific role, because you got to get one job and you have to get really good at it because those nutrients are hard to come by and those resources are hard to find. By contrast, in cold water, water contracts, and because it contracts, it allows for the storage of a lot more other molecules and a lot more nutrients. So you tend to have a lot more productivity in cold waters. Even though you would think that warm waters would be more productive, cold waters are actually far more productive than warm waters. So it holds a lot more oxygen, so more animals can live in it. It holds more nutrients because the water molecules are compressed, and actually nutrients and other molecules can fit between those reduced water molecules. So the water molecules are contracted and allows for a greater density of oxygen and other nutrients to share the same space. Cold water also doesn't evaporate, so it leads to lower, drier temperatures, lower humidity. And because there's an abundance of resources, it puts less pressure on organisms and overall a lower need for niche evolution. So things can get pretty lazy. So why the hell do I have to find a job? There's tons of food at the trough. So there's actually not that much diversity. If you compare Cape bird life, Cape coastal bird life, and Cape marine life to the east coast of South Africa, it's like chalk and cheese. The numbers you'll see in the Cape will blow your mind. You'll see tens of thousands of terns, thousands of seals, thousands of penguins, but just not that much diversity, actually. It's incredible, the numbers, but there's not much going on. Whereas on the eastern shores, you tend to need to look for that life, but when you find it, it's like, wow, there's so many different things to look at. So again, greater populations, lower diversity. And that's the same rule across the planet. When you get to cold waters, you get greater diversity, greater populations, lower diversity. And with warm waters, you get lower populations with greater diversity. And again, so you'll start finding this kelp forest, very productive, full of nutrients. They get all their nutrients from the water and of course from that sunlight. Coral doesn't do well there because it gets outcompeted by the kelp, which grows far faster. Again, you tend to have these salt marshes forming. It's a little bit too cold for a lot of trees, and it tends to also be very dry, which doesn't support that rainfall that trees need to survive. And on top of that, you get these massive schools of fish forming, massive schools, but the diversity tends to be 1 or 2 species, maybe 3 or 4. You get huge schools of sardines, huge schools of tuna, huge schools of anchovies, but not much in terms of diversity. So that's explaining why our actual coastal systems are quite different. Let's go on to the other side of the coast now and talk about Fynbos. Everyone who's from the Cape obviously loves their Fynbos. I love Fynbos, and I think it is a crime against humanity to have eradicated as much of the Fynbos and actually planted it up with all these foreign plants. I think there should be a massive rewilding program for homes in the Cape, and people should not be allowed to plant exotic vegetation. So that is the Cape, Fynbos biome, truly magnificent. Now the soils tend to be very acidic, very well leached, very granular, and that's simply because they are metamorphosized, they're sedimentary material, not metamorphosized. They're sedimentary material made up of very ancient beach sand from when South America and Africa were joined together, and there were these deltas and seas in between the two continents. And now the Fynbos is found in the southwest corner of southern Africa, and it's synonymous with the Cape Floral Kingdom, one of the Earth's 6 plant kingdoms. Now this has got nothing to do with taxonomic kingdoms. It's just a group of plants that live together in a similar habitat. So it tends to contain 2 key vegetation groups, Rhinoceros and Fynbos. And the Cape Floral Kingdom is the smallest of the 6 floral kingdoms, and it's the only one found in one country. So it's unique, and we do not appreciate it remotely as much as we should do. And it's actually a travesty that we don't give the Fynbos the credit that it's due. Now, it has extremely high diversity of plant species, around 8,700 species, and that's also going back to the microclimates amongst the Cape Fold Mountains. Every hill and every kopje and every little valley is slightly different, and has slightly different humidity and slightly different soil conditions, so you get this diversity actually forming in every little pocket. You won't get one species that sweeps the whole of the Cape. It tends to be this guy grows here and that guy grows there. 68% of the species are endemic to the region, so highly specialized species, that highly acidic soil playing a part as well. And also, Fynbos is extremely reliant on fires to maintain itself. Now, that's not only the Cape species. A lot of your Mediterranean species require fires to get themselves going. Same in South America, same in Southwest Australia. So these are the floral kingdoms of the world. You get the boreal, which sweeps the whole of the northern hemisphere, the largest. We get the paleotropic, which is Africa and Southeast Asia. We get the neotropical, which is South America. We get the Australian, which is just Australia because it gets weird. And we get the Antarctic, which is a whole floral kingdom unto itself. Not much going on there, but pretty interesting on all those islands. And again, that has nothing to do with the taxonomic plant kingdom. These are just areas that similar behaving plants live together. So, coming back to the Fynbos, talking about Rhinoceros. Rhinoceros tends to be further north of the Cape Point, and it's dominated by the daisy family. And all these different daisies are shrubs with small, tough gray leaves, and they occur where the rainfall is between 250 and 600 mils per year. And when it gets lower than that, further and further north, because we start to lose those cyclonic conditions coming through, it tends to become a succulent Karroo, which we'll talk about later. The Fynbos, if you've ever been to a presentation in high school in the Cape, you'll know about what characterizes the Fynbos, and that is the Cape reeds, the restios, ericas or heaths as they're otherwise known, and proteas. And of course, daisies make up an aspect as well. But daisies to a lesser extent, the three major components are the reeds, Cape reeds, the restios, ericas and heaths, same thing, and proteas. Daisies playing a lesser role, but they're there, and they're very, very specific to the Cape. Super pretty, super pretty. And Kirstenbosch Gardens, where I took this photo, is an absolute stunner. And if you've never been to Kirstenbosch Gardens, you live in the Cape, slap yourself and go there tomorrow. Truly magnificent. And the grassland biome is one of the largest in South Africa and is actually, again, highly underappreciated. People just see it as, you know, a trip to the countryside, but it used to be inundated with huge herds of eland, huge herds of wildebeest, zebra. It was home to large numbers of white rhino, lions, and that's all gone. I mean, it's all gone. There are very, very few real grassland reserves. KZN's only got really one Nambiti, and it's really not a grassland reserve if you ask me. And we don't cherish our grasslands for the diversity that they actually offer. And again, grasslands tend to ignore most of our geography and our geology, and they sweep right down from the coastal areas right up to the high veld. And they go over the Drakensberg as well into Lesotho. That is a beautiful piece. That took it up in Ezemvelo Game Reserve, which is not Ezemvelo for KwaZulu-Natal, it's Ezemvelo in Mpumalanga. Really beautiful little grassland reserve. If you ever get a chance to go there, if you're near Witbank, go to Ezemvelo Nature Reserve. So the grasslands are mostly found on the high central plateau of South Africa and inland areas of KZN and the Eastern Cape. And the topography tends to be flat and rolling because it tends to be have less geological activity and tends to be more flat and rolling, but includes the escarpment, which is a whole other story unto itself. And the altitude varies and really doesn't play a role in the grassland. The types of grasses obviously depend on the altitude, but grassland itself, not that important. And the rainfall varies from region to region, and this of course affects what grasses grow where and what shrubs will grow in that grassland as well. And it's dominated by a single layer of grasses interspersed with herbaceous shrubs. And there are sometimes trees, but they're usually limited and almost always absent until we came along and started planting trees to make it look like an English countryside. I love the Midlands, of course, you can tell, but they've tried to emulate the English countryside. Those oaks and those ashes and those bushes should all be cut down, and we should try to restore it back to natural, proper grassland. And those eucalyptus plantations are an eyesore. Geophytes, as in bulbs, tend to be abundant, if you ever go in spring, you can have a field day doing wildflower walks. Frost, fire, and grazing tends to maintain the grass dominance. So when you have frost coming in annually, killing off all the seedlings of trees, and fire coming in annually and killing off the seedlings, you tend to maintain the grass. But unfortunately, with global warming, temperatures have increased, and a lot of the areas that were grasslands are now becoming bushveld. Also, likewise, because we've got these fences and these borders, we don't want fires coming into our gardens and into our homes, so we stop fires. That no longer has a role, so bushveld encroachment is occurring. And on top of that, we're overgrazing. So a lot of the areas that are used to be grassland have actually been overgrazed, eradicating all the grass. And on top of having a lack of fire and a lack of frost, all the grass has been eradicated, allowing trees to grow through. If you ever go to Rorke's Drift or Isand Plawana in KwaZulu-Natal, if you look at the photos from 120 years ago, that whole area was grassland. You couldn't see a tree in sight. And now you go there and it's all bushveld. So because of overgrazing. And of course, the lack of fires. So there are two categories of grasslands, sweet veld and sour veld. The name says it all, sweet is sweet and sour is sour. We're not going to go into why they call that. We'll do a botany lesson one day. And they include a wide range of soil and geological types, and they're the most threatened biome due mainly to commercial farming. Commercial farming, if you go into the if you go into central KwaZulu-Natal and Mpumalanga, it's just nothing but gum trees and pine trees, sucking up all their water and completely outcompeting the grasslands. And we should not be farming them in South Africa, but you know, I can talk to the trees and I'll listen. So some beautiful, magnificent, untouched grasslands in Bloemfontein. So going on, again, so you can see it tends to occupy the interior of the country. And again, it doesn't really pay attention to the Drakensberg border. It sweeps right over it and grows through part of Gauteng as well. So the Savannah biome is probably our largest It's the largest in Africa, but South Africa being as diverse as it is, we tend to have quite a bit. I've got a question. Do you know the exact name of pine trees? I don't. I've got a tree book. Tomorrow when we do Q&A, I can answer that question for you. It looks like we've only got 10 minutes left. So if we don't get through the lesson tonight, we'll continue tomorrow night. So the Savannah biome, yeah, we've only got 10 minutes left. We're not going to get through this whole class. So I'll send an invite out tomorrow for part 2 of the lesson, and we'll finish off tomorrow night. So Savannah is, again, otherwise known as Bushveld in South Africa. And it tends to sweep around the escarpment, ignoring the escarpment around the lower areas. And again, that frost tends to what keeps it out of the high veld, and sweeps right through Botswana, Namibia, Zimbabwe, and along the western parts of Mozambique. So it's the largest biome in Southern Africa, not South Africa so much, but Southern Africa. And it's well developed over the low veld and Kalahari regions. And it's the dominant vegetation of Namibia, Botswana, and Zimbabwe. And it has well-developed grassy layers with prominent woody layers of trees and shrubs, and it's very tiered in terms of what it has. You have grasses, you have shrubs, and you have trees. And of course, the density of either one of those three determines the type. Trees may be deciduous, as in they shed in winter, or evergreen, depending on the species and their local adaptations. And it doesn't necessarily have anything to do with the climate itself. So when the upper layer is near the surface of vegetation, it's called shrub veld. When it's dense, it's called woodland. So if you go into Tambuti thicket, for example, you'd call that woodland. If you tend to go into an area with only a few little sickle bushes floating around, you call that shrub veld. And the typical classical bush that we all know and love is called bushveld. Again, it ranges mostly in terms of the altitude, because the altitude is keeping out the frost. And from sea level to 2,000 meters above sea level. Rainfall varies from area to area, and that will dictate what vegetation grows in that area. And also the geology and soil type occurs. They've got multitudes of different soil types, multitudes of the different geology, and that doesn't really affect too much to the distribution of savanna. It's more to do with the topography. So because they have a lack of summer rainfalls, it prevents the upper tree layer from dominating. So it doesn't get a lot of rainfall. So grasses still tend to be very competitive with trees. So there's this nice mix between the two. And because of that, you tend to have a nice diversity of browsers and grazers. So your overall productivity, even though there's limited rain, tends to be far higher than forests and far higher than grasslands. Because you've got both going on. So you've got just an overall very productive area. Pinaceae, all right, that's the family of pine trees. And there's a great variety of vegetation and animal life, as I said, because you've got this very diverse environment going on. And again, you can see over here, this is shrub veld. So you've got a lot of grass with small shrubs starting to dominate the environment. And eventually, if those shrubs become trees and start to outcompete the grasses, you'll end up having a bushveld and finally a woodland. And fires would typically control woodlands because they shoot through a woodland like a ray of light and burn them out and allow grasses to recompete with them. But again, fires are not taking place. And a lot of reserves are becoming Tambuti thickets, because I love Tambuti, don't get me wrong. But we do need fires to happen every couple of years to just break open areas and allow grasses to come in. All right, so we're going to put a pause on that tonight. Tomorrow we start with forests. We've only got like 4 minutes left. We can do a quick Q&A because we've got like 4 minutes. So does anyone have any questions?
Nick, Andre, I'm sorry I couldn't wait for this opportunity, but who defines biomes? Because when I read a bird book and being in the Kalahari last week, I saw there was the Kalahari biome, and you mentioned the Kalahari, but I don't see there's a biome in your spectrum.
Okay, so the Kalahari would just typically be savanna. That's the Kalahari. So if you go towards the southern end of the Kalahari is actually a bit of it's mislabeled. It's not a biome. It's an area. It's a region. A biome is a unilateral area with all very comparable vegetation and animal types. The Kalahari's got both grassland. It's got Karroo, and it's got bushveld. So I would not call it a biome. It's a bioregion, by all means. You can call it a bioregion, but I wouldn't call it a biome because it's got 3 different types of biomes in it. You can also call it an ecosphere. There's lots of cool terms that people come up with these things. But the Kalahari in itself is not one biome. It's 3 biomes together. And again, these, there we go. For most, it's only grassland in the rainy season. But in certain areas of the Kalahari, you get a crap load of shrubs and bushveld. So again, it becomes, how do you define it? So the Kalahari is definitively got a lot of grassland, as Mo says, but it depends on where you are. I've been in areas of the Kalahari where you think you were in KwaZulu-Natal with the amount of dense vegetation that you get. So I'd call it a biome, not a biome, but that's me. Maybe there's an ecologist that can argue with me, that'd be awesome. In the Karroo, you've seen different vegetation. So if you go further north, you'll see more grassland, especially very arid grassland. You won't see too much. In the south, it tends to be far more, you get far higher levels of rainfall. So you tend to get far more woody growth coming on in the south. But if you go north, it becomes far more and more arid, and you get a lot of grassland forming over there. And again, the Kruger isn't really grassland, it's low felt. Yeah, there's Napani north as well, as you're saying, Mo. But if you go on, eventually you get further and further north, it becomes more and more and more open as well. And you get these wonderfully open, arid areas. Wonderful, not for animals, obviously, but it's beautiful to look at. So, and it's a very diverse area, the Kruger. But again, the whole South Africa is very diverse. There's not much left to look at, to be honest. That's the reason why we love the Kruger so much. It's not necessarily because the Kruger is special, it's just that we didn't be bothered to destroy that area before we stopped. Before we started enacting conservation efforts. A lot of these areas, they just realized they were running out of animals to kill, and they said, holy crap, we need to actually have some areas left that we can go and kill animals annually. And that was where the first hunting practices conserved animals. All right, enormous trees in the Punda Maria, Pufari areas as well. Thank you, Mo. Any other questions? Sorry, I just got back from Rhino duty like 10 minutes ago before the class started, so I'm a bit flustered. So I appreciate it if people apologize. Well, sorry, I apologize for not having my head 100% in the game. I literally just got off the vehicle and I had some dinner and I started class. So it's been
okay. Listen, Nick, we're also bloody envious because I'd rather be where you are, getting off the vehicle and being flustered and God knows what, than where I am.
Okay. Yeah.
We saw a lot of baobab trees, and I take it, and I will post some pictures. There's quite an area from about sort of 2 meters down off the trunk, which looks like they could mostly have been affected by elephants.
Yeah, well, they do.
Almost like ring barking.
Yeah, the elephants do
Would
that.
Would that be elephant?
Absolutely. We've got 2 baobabs here at Tula. They were planted by a Kenyan governor like 120 years ago. They don't occur in KZN naturally. And the elephants have tried to huff these things 100 times. They are so scarred from the elephants. And I'm surprised they're still standing, to be quite honest. And the elephants just hammered them. They're very succulent, very juicy. Baobab's classified as a succulent. It's a gigantic succulent, but it's a succulent. And in theory, you can chop down a branch and plant it and grow it. I've never tried it. I should actually give it a try. But yeah.
Okay, I will post a whole lot of photos because I took a whole lot of photos for the group. Very interesting because the ones up the slope on the sort of bottom side of the slope are they not affected as much as the ones higher up where elephants can actually get to them. But it's very interesting to see all these trees because most of them, unless they are out of reach, they've all got that same ring bark, which I should estimate would be the height of an elephant.
Yeah, that's very common. I mean, those baobabs have evolved to handle ring barking, as have marula trees. They're one of the few trees that can actually handle being ring barked 100%. They don't really seem to mind it, and they can bounce back from that. If you guys are envious, if you guys are ever in KZN, you can come do a camp with me. I run the volunteer academy here. It's 1,200 per person per night. And that includes food, accommodation, lectures with me. So we do about 4 to 6 hours of lectures a day. And then we do about 4 hours of actual educational drives, not this fappy nanny game drive stuff. We do proper educational drives and we do stuff. So you guys are interested, you can give me a shout. We're running out of time. We're like 30 seconds left. I'll see you guys tomorrow night, 7 o'clock for part 2 of this. Thanks so much for joining. I will see you tomorrow. Auf Wiedersehen. Adios. Arrivederci.
Auf Wiedersehen. Thank
And Andre,
you.
I'll answer you tomorrow night, Andre. Sorry, I didn't get a chance tonight. Cheerio. Bye-bye.